Hello, ICP class. Today we are going to be working on potential energy equations. So go ahead and open up that document, follow along with me. On the top of the document is your equation. Potential energy is mass times gravity times height. So that's the equation that we will be working with. And I'm going to do the first four with you today. That way you'll have an example of solving for potential energy, solving for mass, and solving for height. You won't really have to solve for gravity. Gravity is gravity. So if we're on Earth, it's 9.8 meters per second squared. And if we have an equation later on, number 11, it gives you the gravity of wherever it is, the location is on a different planet or whatever. We will give you the gravity for that. So for this document, you won't have to solve for gravity at all. But I will do 1 through 4 with you so that we can solve for potential energy, for mass, and for height. All right, let's get started. So for number 1, how much potential energy does a monkey up in a tree have? The monkey has a mass of approximately 11 kilograms and is 14 meters high. Okay, so we're going to identify our variables. 11 kilograms, and our height is 14 meters. So if potential energy is mass times gravity times height, then we have 11 kilograms times 9.8 meters per second squared times 14 meters. And luckily for this, all the numbers are pretty straightforward, so plugging them into your calculator should not be too confusing for you. So if you do all of this, you get 1,509.2. So 1,509.2. And again, potential energy is just energy. So it has the same unit as kinetic energy. And later on, when we talk about total mechanical energy, that also has the same unit. Whenever we're talking about energy, we're talking about joules. So joules is our unit. All right, so again, if you have any questions about this, go ahead and pause, send me an email if you need to, watch it again if you need to, slow it down if you need to. Number 2, a city sets up a hydroelectric dam and they need about 25 million joules of energy produced every second. What is the mass of water that is necessary to create that kind of energy if the dam is 42 meters high? All right, so we have potential energy. And we have height, and we're solving for mass. So if we manipulate the equation to solve for mass, we have mass equals potential energy divided by gravity times height. And if you plug all of that into your calculator, you should get the answer of 60,738.58. So I'll round that up to 60,739. So 60,739. And this is mass. So our unit for mass is kilograms. All right, so again, if you have any questions, please stop and email me. Number 3, you and your friend decide to flip a quarter while on top of the Empire State Building. Sadly, the quarter ended up flying off the top of the building, which is 381 meters high. If the quarter has a mass of 0.006 kilograms, what is its potential energy? All right, so we have a height here, 381 meters, 381 meters. And we have a mass, 0.006 kilograms. And we want to find potential energy. And if we put all of that into our calculator, we should get 22.4 joules. Again, this is energy. Energy is in joules, 22.4 joules. And again, stop this if you need to email me any questions. All right, I'm going to tilt the screen down just a little bit so you can see 4 a little bit better. And this is going to be the last one for today, and then you are going to need to finish the rest on your own. So number 4, you decide to hang up Christmas lights from the second story of your house. If you have a mass of 75 kilograms and 6,700 joules of potential energy, how high are you in the air? All right, so this one we're solving for height. We have a mass of 75 kilograms. And we have 6,700 joules of potential energy. So 6,700 joules. And we want to solve for height. If we rearrange the equation to solve for height, we get that height equals potential energy divided by mass times gravity. And our potential energy is 6,700 joules. Our mass is 75 kilograms. And our gravity is 9.8 meters per second squared. Now, if you plug this into your calculator, and again, meters per second squared is only the unit. You're not actually squaring anything. So it's 6,700 divided by 75 times 9.8. And if you plug all of that into your calculator, you get 9.1. 9.1, and we're looking for height. Height is in meters, so our unit is meters. Our answer is 9.1 meters. Okay, this is all I'm going to do with you guys. You guys can finish the rest. I've solved it for you. Feel free to write down these equations that I have solved for the other variables anywhere on your paper. And again, just like last time, however you want to turn it in is fine with me. If you've printed it out and you're doing it all by hand, you can just take a picture of it and put it into this document. Or if you're typing in the answers and you're just scratching out the work on a scratch paper, just make sure you have the numbers next to each piece of your work. And you can attach that to the bottom of this, make a new page and attach a picture of your work to the bottom. I do want to see your work though, but you can turn it in any way you like. And again, email me if you have any questions. And I will see you one more time in a few days for total mechanical energy.